Okay, so I graded your quizzes, so everyone should have been able to check out their grades. So, just go on the grades tab of Canvas. So if you're in student view, let's go over here. So you just gotta click on grades, and since I'm in student view, it should just show it like this. So you should see your quiz grade here, and your homework too. That was graded a while ago, but yeah, you can check it out. And I left feedback as well. So if you click on quiz 2, it would show your quiz here. Of course, this is like a test student thing right here. So actually it says results are not displayed per instructor settings. Okay. Has anyone been able to look at my feedback?
I did, yeah.
Okay, so you can't see it. Okay. So yeah, I'd check that out, because if you got it wrong, any question wrong, I left you a comment on your quiz itself. And I'm going to upload the solutions as well today. I forgot to before, but I'll upload like a script that I have for the solutions.
Wait, actually, I can't see your feedback. I saw the score, but not the feedback. Sorry.
Okay.
Yeah, me either.
Okay, I'll have to look into that too. Probably another setting. Yeah, and this is kind of weird because it says results aren't displayed per my settings, right? But I tried hiding your score once you submitted your quiz, because like a lot of you saw Canvas grades automatically, and it'll show you out like a 10% or something, because you might have had one really small formatting difference than I had. So I tried disabling that, because you probably did much better than Canvas told you. But then I guess you can't see my feedback. So I'll look into this after class. Okay, so so yeah, quizzes were graded. I think the average was a 77%, so pretty good average. Okay, so you guys can't see the feedback. Okay. So yeah, the average is pretty good. I don't really try to say like, okay, I'm gonna try to get a 70% average or anything. I just make the quiz as I think is fair, and then we kind of go from there. And your second quiz is going to be this Wednesday, so make sure you prepare for that. It'll be basically on everything that we've gone over since quiz 1 up to I guess today, actually, because we didn't cover too much new stuff. So I'll send out another email for what it's going to be on. Okay, yeah, William, you said your quiz says it's late. That doesn't affect your grade for whatever reason. Canvas pretty much said that all of you submitted your quiz late, even though it submits it for you if you don't press submit. So don't worry if it says it's late. Yeah. Okay, so again, I'll send out an email after class for what you should study for quiz 2 this Wednesday. That'll be at the end of class again. 15 minutes long, and because we're doing basic stuff still, it'll be like, a few questions just like quiz 1. Okay, just writing it down so I remember. Also, your second homework is due this Wednesday as well, so make sure you work on that.
Patrick, quick question. We're gonna do a plot next week, is that right?
A plot?
Yeah, we're gonna do plot next week.
Oh yeah, we'll start that chapter, probably next week. Probably on Wednesday, I think.
Wednesday, depending where we are.
Yeah.
Okay, all right.
Okay, so the first thing we'll do, I'll actually go over the quiz with you as a class right now. Let me pull it up. I'm just gonna pull up the file itself. Alright, so if you want to pull up your quiz or just follow along, it's up to you. So the first question we had, let me open up a script actually. Okay, first question that we had was making a few arrays and then making a really basic plot.
Oh wait, are you gonna review quiz 1 through MATLAB?
Mm-hmm. Yeah, right now.
Oh, okay, I see. I thought like you're gonna pop up the quiz.
Oh no, I'll post the solutions later today, but I want to kind of go through it right now too as well. Okay, so the first thing that we have to do is define a vector t using the colon operator. So we're going from 0 to 10 with a step size of 0.01. So pretty basic line of code here. And if we run this, let's also save it. Then this is going to be a row vector. Alright, next thing we have to do is define r. So if you just put e to the negative 2t or something like this, remember if we have our exponential here, we have to type in exp. And then inside of that we do negative 2. And some of you just put 2t, because you know that's what you would usually type out in a different program, but because we're in MATLAB code, we have to specify negative 2 times t. Okay, so that's the numerator, and now we can make the denominator. So we have basically two parts in our denominator here. We have 3 times t and then plus 2. So because of that, we have to wrap it in parentheses, so we have all of that in the denominator. And then we have plus sign, and make sure you're using parentheses here, so sine of 0.3 times t. And if your formatting was a little different than mine, it was very, very likely that you still got 100% on this line of code. Okay, and then we have to plot it, so we're doing plot of t and then comma r. Now if we run this code, where's my plot? Let me put it in the figure command. So you can do figure 1 and this will be the first figure, and then, yeah, there we go. So you can do it like this, or you can do it like we kind of went over last time when I typed in visible, and then we could do on if you type visible correctly. There we go. So that's the plot, but I'm going to put it as off now. Okay, so that's question 1. Okay, and then question 2, we're making a column vector here on one line. So I think, I don't know, maybe like 40% of you didn't get full points on this one. Most of you was just a little mistake, but yeah, let's make sure that we understand both the colon operator, and it was supposed to say colon, not color, and the linspace function as well. So since we're doing it on one line, we're going to have to transpose it, because when we use the colon operator or the linspace function, by default, they're going to be row vectors. So we're going to have to use the transpose function to make it a column vector. So I'll do v equals 10. I'm going to do it using the colon operator here. So we have v equals 10. And our step size is going to be negative 4, because we're going from 10, then to 6, and then to 2. So we're going back 4 digits. And then our last number that we have here is negative 62. So if I just ran it like this right now, it would be a row vector. So if I run it and I look at the workspace over here, we see that it's a 1 by 19 double. So that means 1 row and 19 columns. So I'm going to use the transpose operator to make it a column vector. And now it's a 19 by 1 double. Okay, so that's how you can do it with the colon operator. We can also use the linspace function. So the linspace function here, it's not really ideal because, at least if you're like me, I don't know what the length would be just by looking at this vector straight away. Of course, doing the using the colon operator here, I see that it's a length of 19, so then I know. So I can do linspace. So we're going to start at 10. That's going to be our first argument, and our second argument is the last number that we want to have, so negative 62. And I know that it has a length of 19, or there's 19 numbers inside of this vector. So I'll put 19. And again, right now, this is going to be a row vector currently. So if I run our code, it's currently a row vector. I'll make this a different variable name. I'll call it like v2. Okay, so it's a row vector. So we're going to have to use the transpose operator once again. And now it's a column vector. Okay, question 3. So we had two questions that were very similar, questions 3 and 4, which was making a matrix, but in different ways. So question 3 was making a matrix row by row. So what I mean by that is first making this first row and then making the second row. So we'll do A equals, we need our brackets here. So I'm going to start out on the first row, square root of 4. And I could put a comma or I could put a space to continue on this row. So I'll do square root of 4, then 2, 10. That's our first row. Now I'm going to put a semicolon. And now we're going to build the next row. So 13, 4, and 8. Let's run it. And then we see it right here in our command window. Okay. Question 4. So this, we're going to make the same matrix basically, but we're going to do column by column this time. So that means doing column 1, then we go to column 2, and then column 3. So some of you had the same answer for both 3 and 4. So I don't know if there's some confusion on how to build the matrix using the two different methods or something, but yeah, for this one we wanted to do it column by column. So there's one way that we went over in class, which is doing it like this, where we'll do square root of 4, then we're going to put a semicolon, so we go on the next row, and then we have 13. So let's do this right now. Oops. I pressed F5, which makes that full screen. Okay, let's run it. And so we get a column vector here of 2, because that's the square root of 4, and then we have 13. But of course we want to make this column by column. So to do that, I then want this to do that. Okay, whatever. Okay, so that's column 1, right? And now we want to do column 2, so we're going to have to use brackets again. So that's kind of the difference here if we're making the same matrix column by column instead of row by row. For each column we have to put the column in its own set of brackets. So here I'm then going to put 2 semicolon 4. Now if I run this, we have our first 2 columns here. Now let's go on the last one, which is, what was it again? It was 10 and 8. Okay. So we're going to do 10 and semicolon 8. Now if we run it, then we get the same vector, or same matrix that we just made above, but we made it, using a different method. And we could also make the same matrix by doing, so this will still be column by column, but we're going to construct it a bit different. So I can do square root of 4, and then 13, and what I could do is transpose this. And basically that would make, that should make a, oops, I need to put it out here. That'll make a column vector. So we could keep doing it this way where we build it up column by column, or row by row, and then we transpose it, and then we can make it column by column that way. That's a little weird, so I would personally recommend doing it like line 20 here. Alright, so that's the quiz. Any questions on the quiz before we start doing some new stuff?
No, I don't think so.
Okay.
Someone had a question in the chat, actually.
Right. Yeah, if you transposed it at the end, most likely I docked you a few points, only if you did it row by row and then you transposed it. So let me type this out. So if you did it like this, square root of 4, 2, 10, 13, 4, 8. So some of you did it like this, and then that makes a 3 by 2 matrix, which we don't want. We wanted a 2 by 3 matrix. But even if you did it where you had it as a 2 by 3 matrix and you transposed it at the end, I would have docked you a few points because I wanted you to build it row or column by column. And in this method here, we did it row by row, and then we transposed it. So, yeah, you need to do it column by column and not row by row. All right. Any other questions? Okay. Alright, so let's do some new stuff today. I'm going to make a new script here. And of course, if you, once I get the feedback thing figured out, so you can actually look at your feedback in your quiz, make sure to look it over and check if I, made any grading mistakes or if you have any questions about your grade. Of course, feel free to send me a question then. Alright, so I'm going to do a new script here. The feedback isn't available right now. I thought it was, but apparently you guys can't see it. So I'm going to look at it after class and get that sorted out. Okay, arrays, what's the date? 22nd? Yeah. Okay, so last time I think we pretty much only talked about multi-dimensional arrays before we stopped for the day. Need to fix this really quick, or rather, before we had the quiz. So we're gonna go over that again, and then we're gonna start element by element operations, which is another really important topic. So make sure that you definitely pay attention once we go over element by element operations. So the first thing that we'll do here, we're going to kind of combine review right now on multidimensional arrays and some new stuff. So here we're going to build, no, I won't follow this. I'm going to actually we'll make a multidimensional array right now as a class. So I'm going to make a section here called array addressing with multidimensional arrays. Okay, so let's make a multi-dimensional array here. So let's start out with our first matrix here, and I'm going to build this by using the cat command, if you remember that from last time. So the cat command will basically make, in this case we'll do two matrices on their own, and then we'll use the cat command to concatenate them into a multi-dimensional array. So we'll start it with A, and let's do 0, 1, 2, 3. Okay, so that's one matrix here. Okay, and then let's make another one. So I'll say B equals 2, 4, 5, 6. Doesn't matter. Okay, so we have our two matrices, and now we're going to make a multi-dimensional array. Make a comment here. So I'll do C equals cat, which again stands for concatenate. If I want to make a multi-dimensional array, I have to use a dimension of 3, if you remember that from last time. So I'm going to put 3. Then after this, we're going to put all of the matrices that we want to include in this multi-dimensional array. So in this case, that'll be A and then comma B. So now if we run this, you see in our command window, we have a multi-dimensional array, which is C, and we have two layers here. So we have, remember I kind of explained it where we have layers in this multi-dimensional array. So here's layer 1, and then here's layer 2. Okay, so with these multi-dimensional arrays, such a long word, we can use array addressing. So it's very similar to what we've done before for array addressing, but now we're just adding in that kind of element of specifying a layer as well. Okay, I just have whatever variable name there. So let's say I want to look at the second row and the second column in layer 1. So in this matrix here, I want to look at this value basically. I want to see a value of 3. So I can use array addressing to get that value. So I'm going to type in C, because that's the multi-dimensional array that I want to look at. And then I'm going to put 2, which stands for the second row. And then I'm going to put another 2, which will stand for the second column. And then I'm going to add in a third argument, which in this case will be the layer that I want to look at. So in this case, that'll be layer 1. So now if I run this script again, I should see an output of 3 for this variable sub. Right, and then that's what we get. Okay, brew. Let's do this for, we'll do the first row and the second column for layer 2. So now I want to see a value of 4. So we're going to do 1, comma 2, so that means row 1, column 2. And I want to look at the second layer, so I put in a 2 at the very end. And now I should see an output of 4 for brew. Alright, and then that's what we get. So make sense? Alright, I can also, output an entire row or an entire column or even a range of values within some row or within some column, just like we've done before. Okay, so what do I mean by layer? Let me suppress these here. So we made this multi-dimensional array C here by first building 2 different matrices. So we made matrix A and we made matrix B. They were just a matrix on their own. But so when I say the word layer, I mean basically which matrix I'm looking at. So we made this multi-dimensional array C, which contains our 2 matrices A and B that we created up here. So this was matrix A that we created on line 7, and this is matrix B that we created on line 8. So if I'm talking about this multi-dimensional array and I say layer 1, then I mean this matrix right here. And then layer 2, this is this matrix right here. Does that kind of make more sense? Okay. All right, there's another question. What does what's the 3 for? Do you mean right here, the first argument? Okay. Yeah, so 3, that stands well, that's the argument for the dimension. So if I want to make a multi-dimensional array from 2 different matrices or however many, the first argument for this cat command is for the dimension. So for a multi-dimensional array, that's 3. So let's go back here. And if I instead make this 1 right now, what it's going to do is take our matrix A here and our matrix B, and it's going to make a whole new matrix that has matrix A on the top, and then appended to that below is going to be matrix B. Let me comment some of this stuff out here. Giving us throwing a fit because of that. There we go. So this is matrix A, and when I use an argument of 1 for the dimension, that means append matrix B here below matrix A, and that's what we see here. So it made a whole new matrix, basically. Now if I use a dimension of 2, that's going to append matrix B to the right of matrix A. So now if we do this, let's run it. This kind of area right here, this is matrix A, and then appended to the right of that is matrix B. And then again, if we have a value of 3 for the dimension, that makes a multi-dimensional array. Yeah, so yeah, if we're using a multi-dimensional array, we're always going to use a value of 3 for the dimension. Okay, so let's do one more little example here. So we have our multi-dimensional array. Let's say I want to look at the second row and all of the values for the second row in layer 2. So I want to get these values right here, 5 and 6. Let's see, what's another good name here? I don't know. No, that would be confusing. Okay, dog. Or doge. Okay, so I want to look at the second row. So I'm going to put in 2. And I want to get all of the columns in that row. So I want to get 5 and 6. So I put in a colon. And I want to look at the second layer. So I'm going to put in a 2. And now I should get a value of 5 and 6. Or really a row vector of 5 and 6. Yeah, you got it. Okay, there's another question. What about 3 layers? Do we just put comma C? Yeah, so if I had 3 layers, let's do another matrix here. I'm going to call it D. I'll do 2, 2, 2, 2, because that's inspirational. I don't know. Okay, and then I'm going to put in a comma D, and this time we're going to have 3 layers in this multi-dimensional array. Alright, so now we got a little exercise here. So I want you to build 3 individual 2x3 matrices, so A, B, and C. Don't worry about the range, I forgot to delete that part. So just make whatever 3 matrices that you want to make. And then from those matrices, you're going to make a multi-dimensional array called D. You're going to use the cat command like we just went over right here. And then I want you to specify the value on the second row in the first column of the third layer. Yeah, colon means everything. So if I'm doing it for a row, I'd put a colon, or a column, I'd put a colon. Alright, so I'm going to give you a few minutes to work on this. If you didn't do it for the homework, don't worry about it. The homework is just on completion. I'm not liking the hotter weather. I don't know about you guys. I'm like cooking in my room right now.
Where do you live?
I live in Anaheim.
Oh, wait, okay, I see. It's not that hot in Glen Park for me.
My room gets really hot too because of my computer, so it's not too good right now. Yeah, I really like the colder weather. It was nice for a while. Especially when there was like a lightning storm, I don't know, like a month ago. That's pretty cool. Alright, so let's go over this now. Hopefully you got enough time to work on it. Yep, yeah, same for me. My PC makes my room so hot. I always try to open up a window or something, at least at night. Okay, so first thing we want to do is make our 3 different matrices A, B, and C. So we're doing a 2x3 matrix for each one, so 2 rows and 3 columns. I'm going to do really boring values again. So there's one row, there's 2 rows. B, and then C. Yeah, let's suppress this too. Okay, so we have 3 different matrices that have 2 rows and 3 columns. Now we want to make a matrix or a multi-dimensional array D that consists of those 3 different matrices. And we want to use the cat command. So I'm going to do cat, and because we're making a multi-dimensional array, for the dimension I put 3, and then I'm going to put in all the matrices that we just created. So A, comma B, comma C. Alright, so here it is. And now we want to specify the second row the first column in layer 3. So we're going to look at the second row and the first column in this layer. So I should see a value of 5. So to do that, we do D. I want to look at the second row, so 2, and then the first column, so 1, and then the third layer, so 3. We run it, and then we get our answer is 5. Alright, so that's multi-dimensional arrays. Any questions on that before we get on some new stuff now? Okay, there's a question. A 2x3 is 2 rows and 3 columns. Yeah. So if we're talking about a matrix, we always talk about it in terms like you'll see, if you go in your math class, they'll say M by N. So M stands for rows and N stands for columns. So if I say a 1x3 matrix, that means 1 row and then 3 columns. 2x3 like we just made, that's 2 rows and 3 columns. Let's say 5x4, that's 5 rows and 4 columns. Okay, so Benoit, you want a few more examples? Yeah, we could do that. Do you want to focus more on making the multidimensional array or array addressing? Okay, yeah, let's do that. So I'm gonna unsuppress this just so we can see what we're looking at here again. And I'm gonna actually make these all 3x3s now instead. So I'm just gonna add on another row to all of these. Just put in some random numbers. Okay, so it doesn't matter if you have the same numbers as me, but this is our multidimensional array now. So let's do some more array addressing, and this time we're going to do specific rows and specific columns, and we'll even do a specific range within a specific row. So you'll see. Okay, let's first do, I'll make a comment here. Let's say we'll do row 3, column 2, and layer 2. Okay, so we want to look at row 3 and then column 2 of layer 2. So I want to get this value right here, this value of 2. So to do that, we're going to do D. I'm not going to assign it a variable, but you of course can. So I'll do D. We want to look at the third row, so I put in a 3. We want to look at the second column, so I'll put in a 2. And we're looking at the second layer, so I'll put in 2. And our output now should be a 2. Okay, so that's good. Let's do something a little more complex though. Let's do the entire row right here. So we want to look at row 3 of layer 2. Okay, so for this, we're going to reference the multidimensional array D. I want to look at the third row. And I want to get all of the columns, right? This is one column, this is another column, and this is the third column. So I want to look at row 3 and all of the columns within that row. So I put in a colon. And then we're looking at layer 2, so I'll put in 2. And now we should see basically a row vector of 10, 2, and 5. Alright, and that works as well. Let's do column 1 of layer 3. So for this, I should see an output of 4, 5, and 12. Right? We're looking at all of the rows in column 1 of layer 3. So 4, 5, and 12. So for this, we want to look at all of the rows. So I'm going to put in a colon. And then I want to look at column 1. So I'll put in 1. And then layer 3, so I'll put in a 3. We run it, and then we get 4, 5, and 12. Everyone good so far? I'm going to increase the difficulty just a little bit right now. Okay, so let's do something a little bit more challenging, I guess. So let's we'll modify this just a little bit here. So we're gonna look at rows 2 to 3 of column 1 in layer 3. So now I want to see values of 5 and 12. So the second and third row in the first column of layer 3. So 5 and 12. Okay, so for this I'm going to do D. Yeah, you got it. Yep, that's correct. So I'll do D, and I'm going to do 2 to 3. So that'll be rows 2 to 3. And then I want to look at column 1, and then layer 3. And there we go, we got 5 and 12. So, Long, yeah, you used parentheses around 2 to 3, which you can totally do as well. You know, that can help with readability. So if I do it the way you did it, that also works. But we technically don't need those parentheses, but it can help with reading it a bit better. And let's do one more here. Let's do rows 1 and...
Do we absolutely need commas to differentiate between rows, columns, and layer?
Yeah. For array addressing, you have to have commas, yeah.
Okay, thank you.
Okay, there's also a question, is there a difference between basically a parentheses and a bracket? So, to give you kind of a disappointing answer, it depends. Sometimes they both work in the same way and sometimes they don't. So, but everything that I do here is kind of the convention that is always used. So, for array addressing, we use parentheses. And for making, like, vectors, we use a square bracket. So when I always use the colon operator to make a vector, I always use a square bracket. But, yeah, for a disappointing answer, it kind of depends. You would have to kind of test it, because sometimes, again, they both do the same thing, and sometimes they don't. Okay, so if I want to look at row 1 and row 3 of column, let's say 2, and layer 3. So I want to look at row 1 and row 3 in this second column in layer 3. So I should see an output of 4 and 3 as a column vector. So for this, let's do D. And you'll see in this case, I'm actually going to use brackets, because I'm specifying, I guess, part of a vector here. So this will be D, and then I'll put a 1, comma 3. I'm going to try it with parentheses after. We'll see if it works. I don't know off the top of my head. So right now, this argument here that's wrapped in brackets, this will say that I want to look at the first row and the third row. And now I'll put in a comma and then a 2 to look at column 2. And then we want to look at the third layer. Alright, and then we get our value of 4 and 3, which is what we wanted. Alright, so let's try this with parentheses. I guess I won't say it. Yeah, okay. It didn't work. I didn't think it would work. So yeah, in this case, we have to use brackets if we want to find basically the values of this first row and this third row in the second column in layer 3. Okay, so any questions, guys, before we start array operations? Okay. Alright, so we're going to start array operations, and again, screenshot, I don't know if I'm supposed to look at this. I'm going to look at it. Okay. I don't know if that's just for you, but okay, so we're going to talk about array operations, and again, array operations are really important, so you're going to want to make sure that you pay attention here. I'm going to do a pseudo big section. Okay, you want to know how to fix the black box. when you finish typing in that line, it should have disappeared. It probably showed the black box. Like if I do d equals, well, that's I'll do this again. D1 comma 2. Okay, so this is similar to what you had, and that's just because I didn't terminate this yet. I didn't put a semicolon. If I put in a semicolon, then it's going to clear. So basically, if you see those black boxes and the red squiggly line, it's probably because MATLAB thinks that you're not done constructing that line of code yet. If you still have the black box, then let me know after class. It might be something small like that. Okay, so again, array operations are going to be really important throughout the class. How can you change the color? Somewhere in your color parentheses, or color preferences. I can help you after class though. So array operations, they're going to be really important for a lot of the math that we do inside of MATLAB. So again, important stuff. So we have two different types of arithmetic operations that we have for arrays in MATLAB. So we have array operations, or it's also called element by element operations. So if I say either or, either array operations or element by element operations, that's the same thing. And matrix operations, and we're going to go over that as well, which is basically the kind of math that you'd be doing in 250B. So matrix operations are, as its name implies, they're operations on matrices. But the way they work, right, array operations and matrix operations are different. So we're first going to go over really basic element by element operations with a scalar. So I'm going to have some array, and we're going to manipulate that array with some scalar. And then after that, we'll kind of increase the complexity a little bit, where we are going to be using these same operations, but now we're going to be doing it between two different arrays. And then after that, we're going to go over matrix operations. So I don't think we're going to get to matrix operations today. So the first thing that we have here is scalar vector multiplication. And you know, some of this stuff we've actually touched on before, but now we're going to be more specific with the language that we have here. So multiplying a vector with a scalar. Okay, so if I have a vector like b, so let's say we have a row vector b that goes from 2, has a step size of 1, and it goes to 8. So here's our vector. If I want to increase the magnitude of this vector, so in this case I'm going to multiply it by a scalar of 2, then I can do that. So that's going to basically multiply 2 in every single element in this vector. So let's do, I'm going to basically use what we call update notation. So I'm going to define b once again, but this time I'm going to do b equals 2 times b. And this will basically kind of overwrite the vector that we just created. So now what it's going to do is multiply every single element in this row vector that we have by 2. So that's why we call it element by element operations, because we're going to conduct an operation on each of these elements. So I'm going to do 2 times 2, 3 times 2, 4 times 2, 5 times 2, and we're going to keep going on like that. So if I run this, then there we go. It just multiplied every single element in there by 2. So, you know, really basic, right? But it's going to increase in difficulty a little bit. So I can do the same thing with a matrix, and it's going to multiply every single element or index, however you want to think of it, in that matrix. So multiplying a matrix with a scalar. Also, let's just touch on this too. I could have also done, let's call call this B2. I could do B2 equals B times 2. There we go. And it updated right there, that's why. Let's call this B1. Okay, there we go. And it's going to achieve the same thing. So if I'm multiplying a scalar by some array, the order doesn't matter. I can have 2 times b, or I can have b times 2, and we're going to get the same output. Oh yeah, so you see right here, right? I didn't suppress this line yet, so it's giving me this box around the equal sign and a little squiggly line. And if you hover over it, it says that you should terminate the output. And that just means suppress it with a semicolon. Alright, so let's make a matrix here. We'll have a little refresher on the randy function. So remember randy, so we have an I at the end. That stands for integer. So here I can have a matrix that is going to range from values of 0 to 10. And I'm going to make this matrix a 3 by 3. So we have 3 rows and 3 columns. So if you run this code right now, you're going to have a different matrix than I have, but that's okay for what we're doing right now. So let's do a underscore 1, and I'll do 2 times a. I'll actually make the matrix by hand. I think it's clearer if we can deal with the same matrix as a class. So let's do 1, 1, 1, 2, 2, 2, 3, 3, 3. Okay, there. So let's do a underscore 1. If I do 2 times a, once again, it's going to look at every single element that we have in this matrix A, and it's going to multiply it by 2. So once we run this, a underscore 1, its first row should have all values of 2. Its second row should have all values of 4. And its third row should have all values of 6. Alright, so we get that too. It's, again, pretty simple so far. And then let's do a underscore 2 equals a times 2. And then we get the same exact answer here. So once we get to division, it's actually going to be a little different. Let's see, that's later on here. So, so far the order didn't matter. I could do 2 times a or a times 2, and we got the same output. But once we get to division with a scalar, like you see in this slide, it's going to be different, but we'll talk about that once we get there. Okay, so we can also do array addition and subtraction. So we're doing it with the scalar once again, so it's basically going to follow the same logic that we have. So we'll do addition and subtraction with an array and scalar. So if I have a matrix X that has values of 4, 2, 7, and 8, that's a row vector with a length of 4. Let's make a new variable called x1, and if I do x minus 2, that's just going to subtract each element in here by 2. So our new vector x1 here is going to have values of 2, 0, 5, and 6. We're doing 4 minus 2 is 2, 2 minus 2 is 0, 7 minus 2 is 5, 8 minus 2 is 6. And then same thing with addition. It's going to work in the same way. So let's do x underscore 2 is x plus 2, sure. And then we're just adding each element by 2 once again. So I know, kind of bland so far. But we need to kind of build up from this foundation here. Alright, so let's do it with a matrix as well. With a matrix and scalar. So I'll make a random matrix here called A. Let's do 10, 8, 6, and 4, 2, 0. Alright, there's our matrix, and we'll do A minus 2. Okay, so it's going to subtract every single element in here by 2. And we could also instead do 2 minus a, and that'll work as well. So now each entry in this matrix has now been 2 minus that entry. So let's show this a bit better. So here we're doing basically 2 minus 10, negative 8, 2 minus 8, negative 6, 2 minus 6, negative 4, and so on. Okay, array addition and subtraction between vectors. I think we've gone over this before. We kind of touched on it. And this is also, while we didn't explicitly say it before, this is an element by element operation. Also, just remember, in case everyone needs a refresher here, an array means either a vector or a matrix. Okay, so we'll do R equals, I'll do a different vector here, 0, 2, 4, 6, and S will be 5, 3, 2, 9. Okay, so if I want to add these vectors, so there are 2 row vectors here, I can add them, and once again, we're going to do this element by element. So basically what's happening behind the scenes is we're going to make a whole new row vector called add, and it's going to construct this by adding each of these indices index by index. So it's going to do 0 plus 5 is 5, 2 plus 3 is 5, 4 plus 2 is 6, and then 9 plus 6 is 15. So if we run that, then we have our new row vector here of 5, 5, 6, and 15. Same thing goes if we subtract. So R minus S. And there we go. So it's just subtracting. Same thing. If the lengths were different, and if I remember correctly, I think we actually had this question before towards the beginning of the semester here. If the lengths are different, we can't do this operation. That's on the next slide, yeah. So if I have, let's add in another vector up here called V, and that'll be 0, 2, 1. So R and S, they have a length of 4, and vector V has a length of 3. So those lengths are different. So if I try to do an arithmetic operation here, like addition or subtraction, it's not going to work out because it's trying to do this operation element by element, but there's not going to be the same amount of elements in this vector V. So let's do add underscore 2 R plus V. So what's happening here is it's going to successfully do 0 plus 0 is 0, 2 plus 2 is 4, and 4 plus 1 is 5. So up to this point, we're going to be good, but we're going to get to our 4th index here. So we have R equals 6, and it's going to try to add that to basically something that doesn't exist in this row vector V. So because those lengths are different, we're not going to be able to run this operation. So if I still wanted to add these vectors, I would then have to put it in a placeholder of 0 at the end, because that's essentially what we have for this row vector here. And then we could do it. Alright, any questions so far? I think we're going to get on the more complex part soon here. Okay. So trust me, once we do a little bit more, like especially once we get to multiplication and division between these things, between arrays, that's when it gets a little more involved in, and when you're writing a script, you have to pay a little more attention to that. Actually, go back here. Okay, so let's make some arrays now as well, and we can do these same kind of operations with arrays. So for now, I'm only going to do addition and subtraction. We're going to talk about multiplication and division between matrices a bit later on, because that needs more emphasis on what's actually occurring. So we'll make a matrix A here. Again, I'm going to be boring 0, 0, 0, 1, 1, 1. B equals 2, 2, 2, and 4, 4, 4. Let's actually show those outputs. Okay, so we have A and B, and I can again do addition and subtraction between these two matrices. So they're the same size, and they have to be the same size, just like with these vectors that we made up here, if we want to actually carry out this operation. So I'll do C equals A plus B, and I'll do D equals B plus A. So I'm going to switch the order, but they're going to be the same value in this case here. So again, it's doing this element by element. So we're looking at the, let me suppress one of those. Let's go up here. So we're looking at the first element between both of these matrices. So we're doing 0 plus 2. That gives us 2. Then we go to the second index here. So 0 plus 2 is 2. 0 plus 2 is 2. And then we have 1 plus 4 is 5. 1 plus 4 is 5. 1 plus 4 is 5. So element by element. And it'll do the same thing for subtraction. Okay, I think we already multiplied our vectors by a scalar, right? Yeah. Okay, so like I was talking about before though, if we have division with some array and a scalar, this is going to behave differently than all of the operations that we've done beforehand. At least in the fact that the order does matter. Alright, so I'll do division. Can't type today. So division with an array and a scalar. Alright, so let's make a row vector u. We'll make this 4, 10, negative 8, and 9. Let me suppress all of this stuff. What's not suppressed? Oh, up here. Okay, that was annoying me. Okay, so here we go. We got our row vector u, and we can do u divided by 2, and that's going to go element by element here. So it's going to be similar to what we've been doing, you know, for the last 10 minutes or so. So I could do u underscore 1 equals u divided by 2, and this will look at every single element in here and divide it by 2. So it's going to go 4 divided by 2 is 2, 10 divided by 2 is 5, negative 8 divided by 2, negative 4, 9 divided by 2, ew, a nasty number, we get 4.5. That's not a nice integer. Alright, so that makes a new row vector here. And again, it did it element by element. But now if I change this up and I do u underscore 2, and I do 2 divided by u, and now we're going to get an error. It's going to say that the matrix dimensions must agree. So this is different than what we've had before. You know, when we were doing multiplication, we could have done it, right? It's in this last slide here. We could have still made a whole new row vector by switching the order where the scalar is out in front, and then we did 2 times u. But if we have division, it doesn't work out. And it's not working out because it's trying to take this scalar and it's trying to divide it by an array. So in this case, it seems that we have a dimension of 1 over here, and we're trying to divide it by a scalar which has a dimension of, or a length of 4, rather. So it's not going to work out for division. So that's something that you have to be cognizant of to make sure that you use array by, or element by element division in here specifically. So to do that, you know, so far we haven't been doing anything fancy. We've just been doing a regular old minus sign or a regular old addition sign or multiplication. And it's been, implicitly, it's been working element by element. We haven't had to specify to do that. But for an instance like this, we actually have to tell MATLAB to do it element by element. And to do that, we use a period. So now we can actually create this row vector here. So it's going to create a whole new row vector that has a size of 1 by 4. And again, what we're doing is specifically telling MATLAB to use an element by element operation. And again, we do that by putting in this period before whatever arithmetic operation that we want to use. So like, let's go, I'm going to comment all of this out for now, really quick. And to do this, by the way, I put in Control and then R. Now if I want to uncomment all of this right away, I do Control and T. If you're on a Mac, it's a little different, and I forget the shortcut off the top of my head. So if I go back here, and let's put in a period before these. Oh, I guess that's a bad example here. For addition and subtraction, I guess it throws a fit with a period. But if I go up to when we multiplied something like here, I could put in a period there, and it's going to be the same output that we had before. So let's unsuppress these. Okay, so our output here is, well, you can see it on the screen, and if I modify this by putting in a period before the star, we get the same exact output. And this is because, again, before, without the period, MATLAB was implicitly working element by element. But if we want to be very, very explicit to MATLAB to work element by element, we put in a period. Okay, as we do more examples, you know, knowing when you have to do something element by element or not, it'll start to make more sense. I know in the very beginning it seems kind of weird, so you have to bear with me a bit. So again, back here though, if I wanted to make this new row vector, so if I was starting with this row vector u, and if for whatever reason I wanted to make a whole new row vector that was 2 divided by each of these elements, then I would have to use array division, or sorry, an element by element division operation for division. So that's when I do the period and then the division sign. And then again, that creates our whole new vector here where I'm doing 2 divided by 4, that's 1/2, and 2 divided by 10, 2 divided by -8, 2 divided by 9. Okay, any questions so far? Okay. Alright, we actually already talked about this slide. I think I duplicated a few of my slides by accident. Okay, so, yeah, can I explain the period again? Yeah, sure. I'll do it with a new example here. So I'm going to do this with a matrix now instead. Okay, so division with a matrix and a scalar. Okay, so let's make a matrix A. We have 2, 4, 6 in the first row, 8, 10, 12 in the second row. So I'm gonna first do this like we've been doing it throughout the class so far. So I can do A1 equals A divided by 2. And again, this will implicitly, right now, it's going to implicitly go element by element. So it's going to make a whole new vector or matrix called A_1. And it'll make it by doing 2 divided by 2, 4 divided by 2, 6 divided by 2, go on a whole new row, 8 divided by 2, 10 divided by 2, 12 divided by 2. Right, and that's what we see right here. So now what I'm going to do is make another new matrix called A_2. And let's say I wanted to make this by doing 2 divided by A. So I want to have a whole new matrix where for each entry, I'm going to take the number 2, and I'm going to divide it by each entry in this matrix A. So I want to make this new matrix A underscore 2, where I'm going to build it by doing basically 2 divided by 2. So I should see 1. And then I'm going to do 2 divided by 4. So I should see a half. And we're going to keep going like that for the whole matrix. So if I do it like this right now, we're going to get an error. It's going to say that the matrix dimensions must agree. So again, it's doing this because MATLAB is trying to treat this scalar 2 as a matrix. But, you know, clearly it's not a matrix, it's a scalar. So in this case with division, we have to explicitly tell MATLAB that we want to use an element by element operation. And for that, we put in a period. So that's what the period does. It explicitly tells MATLAB that we want to work element by element. Even though, you know, for some operations in MATLAB, like we've been doing up here, it's been working element by element implicitly. So I didn't have to tell MATLAB to do it element by element, but that's the kind of default behavior. But for this division right here, I have to explicitly tell MATLAB to use an array operation, or element by element operation. So I put in this period before whatever operation I want to do. So now if we run this, it's going to work this time. Does that make more sense? Okay, anyone have any questions on that? No? Okay. That's good. Okay, so what I was just talking about is actually in this slide right here. So, again, a lot of the stuff we've been doing today has been implicitly doing element by element operations, but if we want to explicitly tell MATLAB to do that, we put in a period. So this is a more visual representation of what we're doing. So if I have some, in this case it would be like a row vector, x and y. If I do x, and then I put a period, and then our multiplication sign, and then y, it's going to first do the multiplication between the first index for both x and y, and then it'll do it for the second index of x and y, the third index, and then so on. Okay, so here we go. Yeah, let's do this right now. So this, hopefully it'll start to make a little more sense right now, because you're going to start to see the difference of an element by element multiplication versus matrix multiplication. So I'm going to say array, and then in parentheses, element by element multiplication between arrays. Okay, so let's first make our row vectors here, A and B. So we have A equals 1, 2, 3. And we have B equals 0 to 5. Okay, so there they are. If I want to multiply these element by element, I don't know if you heard that, something just slammed. So if I want to do this element by element, we're going to have to specify to MATLAB that we want to do element by element. So, so basically what I want to see for this output, I'm going to make a whole new row vector C. And what I should get, because we want to do element by element, is C equals, for the first element, 1 times 0, that's 0. The second element is going to be 2 times 2, that's 4. And then the third element is going to be 3 times 5, that's 15. So if I do A times B, which, you know, it would seem like a very logical thing to do, at least if you haven't taken linear algebra. If I do that, it says we have incorrect dimensions for matrix multiplication. So it's going to first assume, because I didn't put a period that we're trying to do matrix multiplication, which we're going to talk about next class. And the number of columns that I have in the first matrix doesn't match the number of rows in the second matrix, so I can't do matrix multiplication. So then it says, then it basically thinks that, okay, maybe they wanted to use element-wise multiplication, which is element by element multiplication. And then if we want to use that, we put in this period before the star. And in this case, that's what we want to do. So we want to go element by element. So we need to specifically tell MATLAB that we want to do that, so we put in a period. So if I run this again, now we get our correct output for C. Also, I quickly want to touch on, like, you know, this didn't work, because again, we were trying to do matrix multiplication. But if you haven't taken 250B, which is linear algebra and differential equations, if you haven't taken that yet, this might be some kind of new stuff to you. But if you want to multiply two different vectors, you need to have a column vector and a row vector, where the amount of rows in one of those vectors is the same of the amount of columns in the other vector. But we're going to get to that a bit later on. Okay, there's a question. For the scalar, it doesn't matter, but element by element it does. If you're doing multiplication with an array and a scalar, yeah, the order doesn't matter. So we saw that up here. So this was with the matrix, and here's with a vector. So up here, the order did not matter. But when we had a scalar and either a vector or a matrix, and we were doing division, it did matter. And that's when we have to be very cognizant of specifying in MATLAB that we want to do an element by element operation. And again, here, once we are multiplying two different vectors, we also have to be very specific with MATLAB with what we want to do. So in this case, again, if I want to do it element by element, I need to put in that period before, and then it's going to run okay. Alright, so I want to get a feeling for everyone. Did this make sense at the end? I'm trying to go very slow and be very methodical here, because it is very important to understand.
Yeah.
Okay. Good. And we're going to, of course, have a little review once we start next class. But this is like when it starts to really pick up, and you have to be very specific or explicit in MATLAB. Okay, so I'm going to end it here. You know, class is about to end in a few seconds. So yeah, we're going to end it for today. Your homework is due on Wednesday, so don't forget that. And quiz 2 is on Wednesday. I'm going to send out an email sometime today for what you should study. And I'm going to try to figure out the feedback issue as well for the first quiz. Yes, second quiz will be based on the homework. So anything that we covered today is not going to be on the quiz. Well, array addressing for multidimensional arrays will be, but the stuff like the element by element operation, that won't be on the quiz. I'm going to send out an email though. Yeah, I'm going to post these solutions. I'll actually post the solutions for the homework tomorrow, because I do want you to see them beforehand, but you should do the homework yourself first.
Are you talking about homework 1 solution?
Did I not post those? I thought I did. But I'm talking about homework 2.
Wait. Okay, when are you gonna post the homework 2 solutions on Wednesday?
I'm gonna post them on Tuesday actually. So I'm gonna post it before the homework is due, just to help you prepare for the quiz.
Okay, cause quiz is based on homework.
Yeah.
Okay.
Yeah, but again, you should take your homework, you know, seriously. It's gonna help you out. So do it first on your own, then check out the solutions. Alright, so yeah, that's it. So I'll see you guys on Wednesday.
Okay, thanks, Patrick. See you on Wednesday.